Hello guys! In this video, I'll cover the log target. We've seen a lot of terminating targets like accept, drop, or reject. We'll shift our focus to a commonly used non-terminating target named log. If a packet is matched against a rule with the log target, the packet headers are logged, and then the packet continues to traverse the chain rules until it is accepted, dropped, or rejected by a rule or by the default policy. Log target is specially designed for logging detailed information about packet headers. It does this via the kernel logging facility. This information can then be read directly with dmessage or from the syslog daemon logs. Note as well that it could be a really great idea to use the log target instead of drop while you are testing a rule and you are not 100% sure about it on a production firewall. A syntax error in the rule sets could cause severe connectivity problems for your users. The log target takes two options that could be of interest: -log level and -log prefix. Log level indicates the priority or severity of the logged message, and log prefix tells iptables to prefix all log messages with a specific prefix or string, which can then be combined with grep to track specific problems and output from different rules. Let's see an example in our testing environment. I want to log and then drop the first packet of any incoming SSH connection, the packet that establishes a new connection, by initializing the TCP three-way handshake. That's the packet that has the SYN flag set. iptables -a input -p TCP -d port 22 -SYN. That's the first packet of the connection -j log. And -log prefix equals, between double quotes, incoming SSH traffic. And the other option, -log level info. Log target is a non-terminating target, and that means that the matched packet continues to traverse the chain. My second rule will drop the packet iptables -a input -ptcp -d port 22 -j drop. From Linux 2, I'll try to connect using SSH to Linux 1. The connection is not working because the packet that initializes the connection is logged and then dropped. On the firewall, I'll execute dmessage to see the kernel logs. These are the kernel logs. Among these logs, we notice the logged packets. We see the log prefix, which is the string incoming SSH traffic. There are a lot of messages, so it could be a good idea to select only the messages we are interested in, and we can do that by using a pipe and the grep command. Dmessage pipe grep, and I want to see only the lines that contain incoming SSH traffic. SSH traffic is enough. And we are seeing only those rules. If I want, I can also redirect these lines to a text file for later inspection. I'm using the output redirection ssh.txt and cut ssh.txt. We see the logs in the file. Dmessage is only displaying a buffer in the RAM memory. If you want to see the logs after the computer restarts or at a later moment, you should read from a specific log file. Based on the Linux distribution you are using, the logs are saved in a specific file on your file system. On Ubuntu, the kernel logs are saved in /var/log/kern.log. Let's see the file using the tail command. Tail -f var log kern.log. -f option means that it will display the tail of the file in real time as data is appended to the file. By the way, tail is displaying the last 10 lines by default. I'm connecting to port 22 on Linux One again. And we notice how the contents of the log file is updated in real time. Note that the log target doesn't save the packet contents, it only saves the packet headers. If you want to save the packet contents, you should use a packet sniffer like tcpdump or Wireshark.